All right, today we're going on a pretty wild ride. We're going to start with the smallest possible packets of reality and scale all the way up to the fate of entire nations. We're connecting the single most fundamental concept in physics, energy, to the future of our civilization. Let's get into it.
So think about it for a second. When you look out at the 21st century, what's the one single force that's going to shape our world more than anything else? What's the deep current that will decide which nations rise and which ones fall? Now, your first thought might be, the rise of a certain country, or maybe some crazy breakthrough in AI. But the real answer, the one that underpins all of that, is something way more fundamental.
It's energy. Simple as that. The ability to do stuff, to create change, to build things, to move. Energy is the universal currency that governs literally everything. And if you want to understand our past, our present, and our future, you have to understand energy.
So to really get this, we've got to go back to the beginning, with that simple, kind of intuitive story of energy we all learned back in school. In classical physics, right, energy is pretty straightforward. It's just the ability to make something happen. And, like it says on the slide, it's a smooth, continuous thing. Think of it like pouring water into a glass. You can have any amount you want. It just flows.
But then, at the turn of the 20th century, that whole smooth, flowing picture of the universe just got completely shattered. We took what you might call a quantum leap in our understanding.
This slide just nails the difference. The old classical view of energy is like a ramp. Smooth, continuous, you can be anywhere on it. But the new quantum view, it's a staircase. You can be on step 1 or step 2, but you can never, ever be on step 1.5. Energy comes in these distinct, chunky little packets called quanta.
And listen, this wasn't just some one-off idea from one person. It was a full-blown revolution built over decades. It started as a crazy hunch with Max Planck in 1900. Then Einstein came along and proved it was real for light itself, giving us the photon. Then Niels Bohr used the idea to finally figure out why atoms don't just collapse on themselves. And finally, the Stern-Gerlach experiment was the smoking gun, the undeniable proof that this chunky quantum world was real. Okay, so if energy is chunky and comes in steps, how does anything actually move? I mean, what rule is nature following to get from point A to point B? Well, the answer to that brings us to one of the deepest, most beautiful ideas in all of science.
Now, you've probably heard this idea before, right? That nature is kind of lazy or super efficient, that it always takes the path of least resistance. But like the slide says, that whole poetic idea, it's actually pretty misleading. The truth is way, way cooler.
Here's the key thing to get. Nature doesn't pick the easiest path. It picks the most coherent one. Think of it like a good story. All the pieces have to fit together, right? It has to be consistent. While the path nature takes is the one where the physics is totally self-consistent, where it doesn't contradict itself. And this is where it gets really wild, thanks to the brilliant Richard Feynman. He showed that at the quantum level, a particle literally tries every single possible route to get from here to there, all at once. And as you can see, all those bizarre, loopy, nonsensical paths, they interfere with each other and just cancel each other out. The only path that's left, the only one that survives, is that single stable, coherent one. And that is the reality we actually experience. Mind-blowing.
So, we've got these deep, fundamental rules of the universe. How do they scale up? How does this rule of coherence build the most complex systems we know of? Let's talk about life itself. This is where physics smacks right into biology.
Welcome to the field of bioenergetics. And really all that is the science of how living things wage this constant, incredible war against chaos. It's the study of how life captures energy, transforms it, and manages it to build order out of complete disorder.
And here's where your brain might melt a little bit. Life does the complete opposite of taking the easy path. Think about it. A rock obeys gravity. It rolls downhill to a state of low energy. But life? No way. Life actively burns energy to climb uphill, to build these fantastically complex structures, and to hold back the relentless force of decay and chaos.
And the absolute master of this process, the hero of this story, is the mitochondrion. These tiny little powerhouses inside all of our cells are absolute experts at energy management. They take the fuel from your food and they convert it into something called ATP. That's the cell's universal energy money. And they use that money to actively maintain this state of high energy and low chaos. That state of precise, functional order, well, that's the very definition of being alive.
So from the bizarre rules of quantum mechanics all the way up to the intricate engines of life, we finally arrive right here, right now, in our world. How are these ancient principles of energy totally reshaping our civilization? Well, welcome to the dawn of the new electronic economy.
For over a century, our world basically ran on fire. We burned molecules. Oil, gas, coal, that was it. But right now, we are in the middle of this massive pivot from a civilization of combustion to a civilization of electrification. And if electrons are the new oil, then batteries are the new pipelines, the new supertankers, and the new storage tanks all rolled into one.
This whole massive transition, it's being driven by one incredible number, $108 per kilowatt hour. Right now, that's the average price for a lithium-ion battery pack.
So why on earth does that number matter? Because it is a staggering 90% cheaper than it was just over a decade ago. A 90% price collapse. That is the engine that's driving the entire electric vehicle revolution. It's the key that unlocked this first huge wave of electrification.
But guess what? The revolution isn't over. It's just getting started. Just look at this comparison on the slide. The next wave is already here, sodium ion. Look at the cost, projected to be less than half of lithium. Look at abundance. The raw materials are literally thousands of times more common. We're talking table salt, not geopolitically sensitive minerals. And performance? It's even better in the cold. This isn't some lab experiment, folks. This stuff is being mass-produced right now. This is the tech that could make energy storage cheap enough for everyone, everywhere.
And this all brings us back to a timeless, kind of brutal, iron law of history. Throughout all of human civilization, one rule has always held true. The nations that have access to abundant, cheap, and reliable energy, those are the ones that rise.
So as our entire world reorganizes itself around the electron, this is the question we're left with. From the quantum staircase, to the mitochondria in our cells, to the batteries in our cars, the story of energy is the story of civilization. And in this new electron economy, the nations that master this new reality, they're going to be the ones who build the future.